Hello and welcome to the channel. In this video we will start a new series in which we will do some problem solving, and this will be language agnostic, so it doesn't matter if you do it in Python or C. We will just consider the theoretical mathematical side of it. So with no further delay, let's get started. The problem we have here is that we have a set of numbers, a set of positive integers, where we have each number n leads to n divided by 2 if it's even, and if n is odd, it will lead to 3n plus 1. So basically we will have a series of positive integers, and you can choose the first number. You can choose this one. It can be whatever you want, as long as it's positive and integer. And then the next elements will be determined depending on the first element. So if this element is even, this element will be n divided by 2, and if this element is odd, it will be n, like 3n plus 1. So let's take an example where we have a set starting by 13. Now we have 13, which is odd, so 3 multiplied by 13 plus 1 will equal 40. So we have 40, and then 40 is even, so we divide it by 2, and then we have 20. 20 is even, we divide it by 2, and then we have 10. 10 is even, so we divide it by 2, and then we have 5. 5 is odd, so 3 multiplied by 5 plus 1 equals 16. So we have 16, and then we divide, and now we reach 1. When we reach 1, this is the end. So the end is always 1, okay? So you should notice that the sequence, the whole sequence, and the length of this sequence depends only on the starting number. So if you change 13, you will get a different series with different number of elements. And the problem we're trying to solve is to find the starting number between 1 and 1 million. And we need to find the starting number in this range that will give us the longest series. So what number in this range will give us the longest series? This is the problem that we are trying to solve here. So we have one notice that that the starting number needs to be below 1 million, but you know, in between, like, it may go higher. So it doesn't matter if it crosses the 1 million line. As long as you started below that line, we are fine. So we need to find that number. So and this is what we will try to do. So let's try by some simple insights. First of all, you will never have two odd numbers in succession. Like if you have an odd number, the next number will be even. And the reason of this is that if you have an odd number, so you will multiply it by 3 and you will add 1. So 3 is an odd number itself, and odd multiplied by odd, this will give us an odd number. Now if you add 1 to an odd number, you will get an even number. So yeah, this is one thing you need to take care of. And but you know, even numbers can be followed by other even numbers, and they can be also followed by other odd numbers. There's no rule here. Like, even numbers can have both, but odd numbers will have even numbers following them. And one more note is that when you have an odd number, like, the series will go up immediately. Like if we have 5, the next element will be 16. If we have 7, the next element will be 7 multiplied by 3 plus 1, which is 22. So this is because of the definition here, that if you have an odd number, the series will get higher in the next element. But if you have even numbers like 8, it will go down like 4, like 2, and finally to 1. So evens means that you're going down, and odds means that you will at least go up one step, like only one step, because after the odd you will have an even, and then you will go down again. So yeah, this is the two notes that I could make out so far. So I'm thinking that, like, let's visualize this. Like, let's draw some kind of a graph, because graphs help us get intuitions very easily. So we are on this axis we will have the numbers, like the values of the numbers, and then on this axis we will have the index of those numbers. So basically we are starting by 13. Actually, no, let's not put 13 there. Let's put 13 here. Like, this is 13. So this is the index number 0. Okay. So the next number, it will be 14. Like, let's put it here. So this is 14. So, and this is the second one. And then you will have 20, which is, let's say, here. And then you will have, this is 20, and this, and then you will have 10. This is 10. And then you will have 5, and after 5 you will have 16, and then after 16 you will have somewhere here, like, you'll have 8, and then you'll have 4, and then you'll have 2, and then finally you will crash to the bottom, which is 1. So this is the end, and this is the beginning. So you should notice that, as we said, when you get to an odd number, the series is going up, and when you get to even numbers, you are just sliding down until you hit another odd number. So you go up again, then you go down when you face evens until you get to 1, and this will be your end. So I mean, this will give you some kind of feeling that you need to have as many odd numbers as you can. Like, if we have many odd numbers, this means that we are going higher more frequently, and this will mean that we will decay much slower, and then we will have a longer series. So, like, if you get what I'm saying, like let me draw let me draw one more example. If you have, let's say, a graph like this, and you have so many odd numbers, like, you will go up, and then you will go down a little bit, and then you go up again, you will go down a little bit. Of course, you will end up decaying, but having odds will make you decay much slower. For low numbers, I mean, you should not exceed 1 million. Okay, this is the limitation we have, but at least we want to decay slowly, so we have longer series, because remember that the longest we go here horizontally, it means that we have longer series. So this is our goal. Okay, and this makes the problem non-trivial, because maybe someone will think that, okay, if I'm below 1 million, so I'll start with 9999999. Okay, so this is the max number below 1 million. And what makes him wrong is that it doesn't need to survive. It may go up one time, and then it decays much quicker than if we started with, say, a less number. So it is not certain that if you have higher numbers you will have a longer series. It is not necessarily true. So our task is to find that magical number, let's call it x, that will give us the longest series ever in this range, of course.